So welcome to day 3 of the series where I will be explaining you the code, the infrastructure as whole, and what is the code beneath it. So we will do the code setup for the deployment, the manual deployment first, and I will explain the code for better understanding. So let's go through the code once. So I have given the repository, the actual repository where the Terraform file is there, where every infrastructure as code is there. So I will just copy this whole part and then I will paste it in our current repository. You remember we have just created the repository in the previous part. So I will create first one folder here, and the folder name is Terraform, and inside that I will paste all the necessary files to create the infrastructure. So first of all, I will close everything and I will create all the files here. So I have created couple of files here. So let's go one by one. So first of all, I at least hope that you have understanding of Terraform and how it works. We will do the whole infrastructure as Terraform. And then if you have any doubt, or if you don't know Terraform and how to use it, please refer to the earlier videos of mine where I have explained how Terraform works and how can you deploy your infrastructure with Terraform. So this is not a Terraform learner video. So I hope you know something about Terraform so that you can follow me through. So now let's go to the particular files and let's explain it, what it does. So as you remember, the purpose of the video is to create an infrastructure which will run a container image into our Docker ECS Fargate. So for that the infrastructure to be work, I want that infrastructure to be deployed with Terraform. So for that, this Terraform coming into picture. So first of all, let's go to providers. So the first of the provider is AWS. So I have created a provider of AWS and the region is var AWS region. So what is var? It's a variable that I have to define where AWS region is. So if you open the variable, so the AWS region is defined as US East 1. Now let's go back to provider again, and I am using Terraform AWS version, HashiCorp AWS version greater than 4. And then I am also using a backend to store our Terraform state, and I am using a bucket. So this bucket we have to create. So we will create this bucket, and the name of the bucket is this one, and the key is this. The region is US East 1, encryption is defined, and also using the log file. So we are not using the traditional DynamoDB locking, rather we are using the S3 locking, which is a very new feature of Terraform. So this is the provider. So first of all, what we have to do, we have to create a bucket for this. So let's go back to our AWS account, and then we go to S3 and we create a bucket. The bucket name is this one, and let's see if the bucket is available, and the bucket is available. So my bucket is there. So the bucket is created. All that you have to do manually is create this bucket, and after that my provider will be initialized, and the second part is creating the VPC. So to run a ECS Fargate, you always need a VPC. You need to run it inside a VPC. So for that, I'm creating one VPC. My VPC name is main, and the name is main VPC. The CIDR block is defined here under variable. So the VPC CIDR is this one, and then the DNS support is true and DNS hostname is true. I am creating two subnet. One is public subnet, another one is private subnet. And the public subnet is something that is, and also I am creating one internet gateway, and the public route table is associated with my public subnet. So this is my public route table, which has a CIDR block route going through the internet gateway, and the public route table association is with my public subnet. So that's it. Basically, the private subnet is for the resources under private subnets is going nowhere. It is locally. but the public subnet is going into the internet. So this is where the VPC comes into picture, and I have defined this very simple VPC with two subnets and one internet gateway, one route table. That's it. We don't need a huge infrastructure for this, but in production you might have to create two subnets in two availability zone just to have more scalability in your application. That's it with the VPC. And then we come into the ECR. You remember, ECR is something that you have to hold your images, or you have to store your images somewhere. So this is where the ECR comes into picture. So ECR is something, I'm creating one ECR, and the name is ECR repository. Where is the name? So the name is here, my application repo. So this is the ECR repository, and the image tag is mutable, and the life cycle is destroy false. That means whenever I want to destroy this infrastructure, so the ECR repository also will be deleted. So this is a very simple thing in Terraform. So I'm just creating an ECR repository to hold my images. Now comes the very important part of ECS. So for ECS, container service to work, there are a couple of things we need to define. First of all, we need to define a security group. So I am creating one security group, and then the cluster. So actually, Elastic Container Service actually runs its service or task inside a cluster. So we have to create a cluster. So I'm creating a ECS cluster, and the name is this one, which I have defined here, my ECS cluster. And then we are creating a log group with the name ECS my container, because we want to view our job logs there. So this is where the logs coming into picture, and this is the logs. And then the IAM role, we have to create ECS task execution role and ECS role as well. So the name is ECS task execution role, and the assumed role. So this role will be assumed by ECS task, and the role policy that I am attaching is ECS task execution role policy, which is a service role coming from AWS directly. So I'm creating one role, and on that particular role, I'm attaching a policy named ECS task execution policy. And then the most important part is the task definition. We have to create the task definition. We have to define a family. So the family is ECS task family, which I have defined here, ECS task family. So this is the name that we have to give. And then the network mode is AWS VPC, because we have, remember, we have created a VPC under this vpc.tf. So we will run it under AWS VPC. And the requires compatibility is Fargate. You can run it, you can run your instance, or you can run your container image with EC2 as well, but I will use Fargate, or we will use Fargate here, so that we don't have to manage our servers. Then the CPU and the memory is defined here. So I am giving very less CPU and memory, because it's a very simple Python job that we will be running. And the task execution role and the execution role and the task role, those two are same that I have given. So basically, this role that we have created, ECS task execution role, this is the execution role and the task role as well. So in production, you might want to create two different role for the task role and the execution role. But for this demo purpose, we can attach this one role to this both entity, no problem in that. Then the container definition. So the name is container name, and then the image, from where the image will be taken, from the ECR repository with the latest tag that we have defined before. And the port mapping is something under port 80 it will run, and the logging configuration is the CloudWatch log group that we have created, and it will have a ECS prefix for that log group. And also we are creating one service delivery. So this is the task that it will run, but apart from that, we are creating also one service so that it will run every time. Because so ECS service is something when you say that, hey, I want this service to be available for 24/7, right? And the desired count, you can mention that how many tasks you want to run at a time. So the desired task is kind of one in the ECS service. and the name is this name. The cluster is where it will run the service, and the task definition is the one that which task it will run, and the launch type is Fargate. And the network configuration is where we have to give the subnets and the security groups that we have created, and the public IP assign is true that we have given. So this is a very simple ECS service that we have defined. You might not need to create the service if you only want to run the task manually, or with a scheduled definition of event bridge. If you want to run the task, then you don't need to create the service. But if you want to run it continuously, then you might want to create the service so that the service is running the task for you, and always the desired count will be matched. So if your desired count is 2, then 2 tasks will be spin up. If your desired count is 1, then only 1 task will be spin up. So this is the difference between a service and a task. That's it. Basically, I am outputting couple of things here. One is the VPC ID, subnet, ECR repository, ECS cluster name, and very important stuffs. Nothing fancy, and that's it basically. So this is the whole infrastructure of creating the repository, the ECS service, and the task with Fargate. Now what we need an image to create, right? We need to image a Docker. We need to create a Docker image so that we can push the Docker image to our ECR repository. So for that as well, I have one small code that I have written. I also have pasted that in the in the repository that I have given in the description. You can take that. So that is very important. And that code actually does nothing. So let me show you the code first. So I have also now taken the code from the repository and pasted it here. So first of all, we have to give a Docker ignore file so that not everything goes to your repository, or not everything goes to your Docker dependencies. And then this is the Dockerfile. So if you are not familiar with Dockerfile, so I think this is a very simple one. Dockerfile is something that is used to build your application in a Docker image from taking up one operating system. So I am given here from Linux or Python, from Linux or this repo. So why I have given as platform Linux or AMD6, because I'm running it in the Mac OS, and sometimes it is very it's not ideal, or I have seen some problems if you not define platform Linux or AMD64, because then it will fail while running in the Docker file into the Fargate. So it will either take Linux or AMD64. So for me running locally, it will take this one, and for Fargate it will take Linux. And from Python or Slimbuster, so we are taking the image, and then we are defining a working directory, and then copying the program.py to the current working directory, and then running the program.py. So what is inside program.py? It's a very small Python program where it is defining a hello world from ECS Fargate. Then it will go to sleep for 20 seconds, then it will sleep for 20 seconds, and then wake up and say goodbye, and that's it, my Python program. So this is a very easy Python program. So why I have given a 20-second sleep? Because I want to check the logs, or I want to see that my service or tasks is actually running inside the Fargate. Because if you don't define the 20-second sleep, so it will just run and disappear. So you will not be able to see the running functionality in the Fargate. So that's why I have given a wait time here, and that's it. So this is the concept actually. So think of it in this way. Suppose you have a very big Python job which need to run for more than 30 minutes or 40 minutes. This is the correct way of running it into the Fargate. You can also run it in Lambda, but Lambda only runs for 15 minutes. So the longer runtime jobs will not run into this Lambda in your Lambda. So you definitely need to run it into your ECS cluster. So this is another important stuff. So you can make this program bit more complicated. Then you need to also install all the dependencies for your program here into the Docker file, then build up the Docker file, and then push it to your ECR, and then Fargate will take it and it will run it. So that's it in the program, and I hope I have defined everything, and I hope you understood the concept about this Terraform file and everything, what it will do infrastructure as code. And I hope you enjoyed this video. So that's it for today for this small part of this video. This is the third part. So on the fourth part, what we will do, we will manually deploy our infrastructure into the AWS account, and then we will see the jobs are running. We will also see our program is running into the AWS account. So that's it for today. How to deploy and what to do, I will be doing that in my fourth video. So I hope you have enjoyed this video. Please, if you are new to this channel, kindly like, share, subscribe, and comment your thoughts. I will be back with the fourth part of the series where we will be deploying the infrastructure now, where we will be deploying all the code as an infrastructure into the AWS account, and I hope you will like it. So I will be back with the fourth part, and then till then, take care and goodbye.